Yo, 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 let's go. What's up, everybody? Good morning, Fabik, even though you haven't gone to bed yet. And thank you so much for the donation. What a great way to start the stream. And good morning, Cooler SK. Water indeed. We're gonna continue with the water today. But I think it's moving quick now. Okay, so let's take a look. What I want to do now is when we pour the water like this, we start pouring it. Whoa, what's happening? Maybe not the best visuals, but so far, but we can improve them. So we start pouring water here. It gets poured down. I wonder why we're going this. We're going pretty broad here, though. Anyway, we find a minima here. And as soon as we find a minima, that flow, the initial flow to the minima, gets removed and we get something like this. And we start pouring out water from here. I would like this flow to remain. I want this flow to remain while we're pouring water, and this one grows. Because the idea is that the character will stand here, pour water while this one is growing. Okay? So that is what we're gonna do first. And the second thing we're gonna do is that when we have something like this and we start pouring water again, we're not gonna reset the previous result, we're gonna build upon it. Okay. Cooler SK Rocket probably still has no idea when I say water and water. It's some song, I think you said. I'm gonna have to do some research. But okay, where do we have it? Terrain, fluid, solver. So I think it's this task right here. I think we're currently working with water temporary when we do the check for fluid overflow, but I think we can work with water instead. So we're gonna get some performance out of it as well. Yeah, the fluid amount here. Let's see here. We find a minima. We want to set the initial fluid amount to be equal to whatever fluid amount we have at that minima. And then we want to do this. I think. Everything is committed here except for two very small changes. Yo, what's up, PG King? Good morning. So check for fluid overflow here. don't think we want to clear this one. Oh, PG King, thank you for the Prime. Appreciate it, appreciate it. Hopefully you can enjoy the stream without commercial breaks now as well. That's always a plus. PG King, I really enjoy lurking on your streams and get to see the advancement. Yeah, thank you, I appreciate it. I appreciate it. Always nice to have people with you on the journey, you know? Okay, so when it comes to this water temporary here, I don't think we want to... In fact, we clear it here. I wonder if that is a... Move data water previous to water. Okay. Apply data type. Yeah, I wonder if we can just do this. Let's see here. In find reachable minimas, we skip clearing this one. No. In check for fluid overflow, in this one I mean, we remove clearing this one. And when it comes to check for fluid overflow, m set value, water temporary, m get value, terrain data type height plus fluid amount. No, what we want to do here, I think, is... I think we just want to set water here and fluid amount here. Because we're gonna increase this one quite a lot. I think we're gonna do it like this. But then we have to change also, so when we spread fluids, it's going to be water. When we check this one, it's going to be water. And then we don't need to move the data here. That is also going to be quite an improvement. The only thing now, or the biggest thing we need to do, given these changes, are this one here. We don't want to set fluid amount to 0 here. We want to set it to... Let's see. I think we want to set it to... Oh, we wanted to fix this one as well, I think. New value. Height. Yeah, here I think I want to do if height is bigger than water, then we do height this one. Otherwise, we just do... I think I want to change this one to, for each affected point, I just want to do if AP get value, if height is bigger than water, then I want to set AP set value terrain data type water, and then we want to set it to AP get value terrain data type height plus fluid unit. So it's basically this. So what this one does is this one alters the data, the water data, in such a way that we can render it. And previously we did, so if the height of a point is bigger than the water point, then we set the water visuals to be height plus fluid unit. If this is not true, we set it to be equal to water plus fluid unit. So if we were pouring out water on already existing water, we would actually show the newly poured water on top of the existing water, which is quite weird. What we do now instead, so like we're just pouring water. If we're pouring water on a point where we don't have visible water, then we want to visualize the poured water. If we're pouring water on a point that already has visualized water, then we don't do anything. Then we just visualize that water. Might seem a little bit strange, or my explanation might not have been the best one, but let's see. So back to here. So we're done with finding the minima. So now we want to find the non-overflow fluid height. We start with adding a fluid amount of 0, but that's not exactly what we want to add. We want to add, or we want to set this one to minima dot point dot get value terrain data type water. I'm pretty sure this. I'm still a little bit we'll see. Exactly like this. So we still have the, and if we quit, we get this. Beautiful. And if we add new water, oh, fucking great. That's exactly how we wanted it to work. And if we quit, okay, we might have quit too early there, I wonder. There we go. Yeah, we still have to fix the exits so we don't, I wonder if we have, this one is done now. Yeah, we have one issue here. Fix issue where exit early makes reverts one step. Beautiful, thank you Fabricape. I think so as well. It was a bit easier than I anticipated, but yeah, let's try it on. Yeah, we need to fix this as well, but we can play around with this, the flow here as well, because we need to make that one a little bit prettier. That's for sure. Actually, I wonder if it has to do with us not flipping them. Let's see. Yeah, we're probably gonna make it a little bit prettier by just flipping these. But then again, it won't look that much better. We're gonna have to add some variation as well, but we can do that with a shader, I think. And we can control the edges here a little bit better. So yeah, we can do a lot of things. So for instance, we can add a random value. So to this one, when we're doing the flow, we can set these edges to be equal to so if we move from this point to, oh, maybe we don't even move. Ah, that's true. We might not even be exploring this one. We're always moving in the quickest direction, so the one leaning downwards the most. And as soon as we find a minima, we just quit. That's about it. But yeah, flipping... Ah, yeah, okay, so this might be a bit harder than I first thought. To make the flow be pretty... But actually, when I think about it, I thought we had a better flow previously. A nicer one. Okay, that's bad. I thought we had a little bit of a cleaner flow a few days ago. First of all, it was thinner, way thinner. We actually flipped these. Right? Yeah, we do. Find minimas. So when we do update fluid mesh data, we actually flip them here. Okay, so that might actually be destroying more than it helps in this case. I want to see what happens with the flow if we don't flip the quads. How does it actually move here? So I guess it moves from here. Quit this, we're gonna do this, and then we're gonna jump up to find reachable minima. Get neighbors. Do we need to order them? Nah, that's... Or is it because we have a diagonal cost? I just remember it looking a little bit better a few days ago, but yeah. Yeah, what the hell can we do about the flow here to make it look a little bit better? Let's see. Find reachable minima. If height is bigger than water, then we just set it to height plus fluid unit. Yeah, that makes sense. Yeah, cool rescue. Hopefully we will change the color of the water today. Hopefully. Finally gonna make it blue-ish, see-through-ish. Affected points. Oh, that is true. We add. Yeah, what the fuck? We add every neighbor to affected points, and then we fix affected points like this. I think we will get a better result if we don't add every neighbor to affected points, but we just add P to affected points. I want to try it at least, see what we get. Rebrick, thank you for the follow, appreciate it. So it's this one I'm a little bit worried about. Affected points. We add MP to affected points. So we add the start point to affected points. I probably want to do it like this. We remove this one from the neighbors, and then we add it here. And we do, as long as affected points doesn't contain P, then we add P. But then, yeah, so as soon as we find a minima for a P, then we just quit this. This might look a little bit better at least. Let's see. We're way thinner at least. interesting. Very interesting. It's a little bit too thin for my liking, definitely. And then we have it grow like this. Yeah, that's not, it's not pretty. But yeah, it's a bit too thin for my taste. Okay, here we go back to the old solution, I think, because it dries up over here. But if we wait 1, 2, what? 1, 2, 3. Okay, if we wait 3, then it's okay. I wonder what happens. And then we can actually do, so here we have a little bit of a downflow down to this water here, but we can actually start filling up this one as well. If we want to remove that downflow, I think we can do this. Yeah. Slowly but surely, we're making it like this. Okay. It can be good for leaking fabric. The thin stream of water we get here. And maybe. I want to see what happens if we go. Oh. Ah, my. Okay, so here we have flips as well, which makes it not visible. Yeah, it's all about how should we set up the mesh or the initial flow to make it possible to animate it nicely. It's, first of all, it's way too thin. So what we actually want to do here is yeah, I'm pretty sure. Okay, so listen to this. First of all, we don't want to flip quads here, I don't think. Because that is gonna screw up the flow a bit. So first thing, we don't want to flip the quads when we do the thin flow from wherever the character is pouring water. Second of all, we want to take every neighbor to the final flow point. So in this example, for instance, we add a lot of let's see here. Yeah, we add a lot of neighbors. We add a lot of neighbors to unvisited points. So when we quit down here, when we have a minimize found, when a minimize found, that means that we won't be doing this anymore. So we know that in unvisited points here, we have a lot of neighbor points in unvisited nodes. So I think in this case, the unvisited points would be this one, okay, this one, 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 this one. this one, 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 and this one, I think. And if we have those, we have a pretty good control, like, over how we can visualize this. So for instance, when we do this in the end, so for every affected point, that's the ones that are actually within the flow. For all of these, we set the water value to be equal to height plus fluid unit. But then we could also do something like this for each bar P or N in unvisited points. So here we know that all of these are edge points, so we could probably set them to, we could probably do, first of all, I want to do the same check. I'll do this check as well. One sec, I'm just gonna lower the music a bit. Okay, there we go. So here we know that every point here in unvisited points is going to be a neighbor point, i.e. a point that is connected to one that is visible. Cooler SK, there is music, question mark? Yeah, for me it is. Unfortunately, due to previous like copyright problems, even though I follow all the copyright instructions I know, I've still had some problems, so I don't really dare streaming the music I play right now, unfortunately. But so we can control these, and what we could do here is we could set them to, we could pretty much set them to something like this. Would it be crazy? So we could do, I just want to try this one real quick. First of all, I want to fix the when we flip the quads, flip quad, update fluid mesh data. Update fluid mesh data. I just want to do this for now, and then we do this, and we remove this one. And update fluid mesh data and flip quad. We want to do it everywhere except for here. And then I also want to try, so there's 4 unvisited points here. We're gonna do, we want to do this check, I think. No. Or yes, we do. We do. If n height is bigger than n water, if so, n dot set value terrain data type water, and we can do something like n get value terrain data type height plus, and here I wonder if I want to do math f or random thought it was random range or something like that. Unity random range. but I guess we'll need to do Unity engine random.range. Random, what do we have? Returns a random float within 0 and 1. Range, let's go with this one. Min inclusive, max inclusive, great. So I think we want to do 0 and fluid unit here. So basically, and then we want to do mathf.round to int here as well, I think. So if we have a neighbor value, i.e. one of these, at the end when we have found a minima, we set the water value of this one to be equal to somewhere between the ground and the ground plus fluid unit. So if this one has a height of fluid unit, this one is going to have somewhere between this ground level. How can I explain this? We're gonna add more and less water to some of these neighbor points, and hopefully that will look kind of good. We might need to clean it up using the shader later on, but let's see what we have. We get an error. Random range int can only be called from the main thread. The fuck. Okay, then we do it with a little bit tired from all the Unity stuff that can't be called from a secondary thread, but okay. So let's see, C#, what's the random int in C#? So random RND new random. Okay, beautiful. We're gonna do this instead. Yo, what's up, Mr. Quote? Long time no see indeed. Yeah, so let's use C# random instead. And yeah, we're gonna do it like this. System.random. Random is equal to new system.random. And creates a number between 1 and 12. Okay, so it's inclusive, exclusive. Fabric-wise system random. We can't use Unity engine random on a secondary thread, so you can only use this one on the main thread. And we want to randomize the height of the water to give it some, to give the flow some randomized feeling. Make it a little bit thicker, but randomized. But okay, so this is inclusive and this is exclusive, right? So we're gonna have to do Okay, so then we just do plus random dot next between 0 and fluid unit plus 1. Oh, nice with system random as well. We don't need to cast this to int. Or round it to int. Okay, let's try something like this. The visuals are still going to be highly dependent on the mesh topology or resolution of the mesh. But we'll see what kind of result we get from this. Didn't we get a better result? First of all, we're still flipping quads here. And second of all, we're not getting... We're not... Okay, we didn't really get any change. What did I miss? Find reachable minima. If height, if n, unvisited points. Is unvisited nodes not what I think it is at this point? We take the first point, we take all the neighbors, we spread fluid to the neighbors. If ooh, one sec. What the fuck? Water temporary bigger than water. Water previous to water. So all of this one does is, yeah, okay, I've screwed up a bit here. Let's see. Find reachable minimas. We're working with water temporary here. But what the hell? How is it even possible that we get... Ah, never mind, never mind. Okay, so if height is bigger than... Okay. And if height, then we set value water to be equal to... Ah, Still not entirely sure what exactly is happening here. We work with water temporary at all points. We get a good flow from that. And then we don't, like, the only thing we do with water temporary is we build up affected points and unvisited points. Because then we set the water using this instead. But why? Okay, so this one is true for all affected points. Then we set water. Okay, yeah, this works. But why doesn't this one work? I want to know. Unvisited points. We should have a lot of points here, and we check if height is bigger than terrain data water. If so, set water equal to n random next between 0 and fluid unit plus 1. Okay, let's do or what the hell? Unit engine debug.log. I just want to know unvisited points. A little bit perplexed by this. Unvisited. What the fuck? $38 unvisited points. Is that roughly what we're looking at? 1, 2, 3, 4, 5, 6, 7. I could probably be correct. Okay, so we have a lot of unvisited points. Why the hell don't we add... Like, I want to add... So for this point here, we want to put it up. I know. The fuck. I know. So what we want to do is... so we actually do all of this, but we never update the actual mesh for these points because these points don't exist in AP or in affected points, and we only update the mesh based on affected points. So we set the value in the texture correctly, but we don't alter the mesh based on those values later on. So we need to do if n I guess we want to do, I think we can do if fuck, do I want to do contains n? Like the first iteration, this should be false because we only add p's to affected points and not n. But affected points, we never reset this one between iterations, so the next time around we might already have them in there, so we want to check this one. Possible improvement in the future. Possible improvement right there. What the fuck? That looks like shit. Of course it does, of course it does. Because, yeah, we're always moving above. Yeah, we want to be a bit more... What the fuck, I don't want to flip quads here. Why are we still flipping quads? I don't like that. Why are we flipping quads here? Or is that actually... Oh. We're probably doing it down here. Yeah. Okay, but anyway. Okay, so what we did now is that every neighbor is always above the ground or almost above. I think we wanna add some more randomization to that one. I think we want to do... What happens if we do... So we do... Between fluid unit +1 and... I think we're going to do it like this. So we do a random value between 0 and this one plus this one. But that might be too big. We might want to make this one a little bit bigger. Because it feels like we're often going to get... if we're extremely far up, we're going to get... Okay, let's see how I should put this. So then the edges of the water is going to be decided by the neighbor heights of the water. And what we do here is that we set the neighbor heights of the water to be equal to a random value between 0 and the height at that point plus fluid unit +1. But what this means is that if we're extremely far down, so close to the 0 value, we're going to get broader water flows. And if we're extremely high up, we're going to get thinner water flows. Because if we're close to the 0 value, there's a bigger chance that the value will be above ground. And if we're far away from 0, there's a bigger chance that the value will be below ground. So, but I just want to try this, see what kind of result we get. So we always want to make both this one and this one decide on the height, or be dependent on the height here. So we could go and get value terrain data type height plus random next between minus fluid unit +1 and fluid unit +1. But let's see. It's a little bit better. I'm still not entirely sure about definitely need to flip here, I think. Need to flip here. Yeah, we're flipping in a few cases where we should not be flipping. Still a little bit. Okay, so what if we do this instead? Get value height plus random next between something like this. But actually this one is inclusive, so we just want to do this. Inclusive, exclusive, or exclusive, inclusive. So now we're doing random next between minus fluid unit and fluid unit. I don't know how salvageable this is or how pretty we can do this one. Yo, what's up, UdeV? I'm trying. Here it's pretty. Here, I don't know what the fuck is going on. If we would have been... If we had... Yeah, it's the flipping. It's the flipping of the quads that screws us up. I mean, this part looks quite good. This one looks like shit, and I wonder... I think we're gonna have to do some for the flow. We're probably gonna have to do some shader stuff, I think. Actually, what you could do is let's see, what if we do... Let's just do... fluid unit... plus fluid unit, or just 2, or no, -1. Because I wonder, I wonder. Okay. We get a weird flip here for some reason. Or we don't get a flip here, that's true. Yeah, Deb, I felt pain in that, okay. Yeah, there's a lot of pain in this stream, but it's joyous pain, I promise. Joyous pain indeed. And this one looks pretty good. This one doesn't. Oh, we even get the correct normals here. That's fucking beautiful. What the hell is happening here? This one has water. This one has water. This one does not. This one does not. So if we would be having, okay, what if we do this, but we also flip like we previously had it? Why the fuck do we flip this one? Is it insane? It shouldn't flip this one. No, it shouldn't. This one has water. This one has water. Never mind. Oh yeah, we need to improve the when and not to flip quads, because what's happening here is that this one doesn't have water, this one doesn't have water, so we don't flip it. But if this one has water and this one has water, it should always take precedence. I think it's the same here, right? This one, I think so. Tube dev. At this stage you might as well rename it from water to fluid, since it might as well be tears. Wow. It's ironic because it's not pretty enough to be tears, I don't think. But we're gonna do it like this. Okay, that's true. It could be snot. Definitely, definitely. Let's see here. How do we want to do these checks? If... Okay, we take a look at this one. If this one has water and this one has water, we don't want to flip. If that isn't true, we want to check, does this one have water and this one have water? If so, we want to flip. If that isn't true, terrain patch, I think it is. Flip quad. Yeah, right now we just flip if they are not equal. So we're gonna do... I think we want to do this. Terrain point. Then we're going to do terrain point. No, this is not. Let's see. So for this point, we always get the positive one. So if this is the point we have, we get this one. But then we want to get this one and this one. So we're going to call... I'm going to do this. D, and then we're going to do... We're going to do this, and I think we're going to do... If any of them are null, we just move on. We want to do some tests here. We want to do, first of all, so I think the most important part is if P has water and D has water, we don't want to flip it. But okay, how exactly do we want to handle this? Okay, I'm gonna do it. Okay, first of all, if this one has water and this one has water, we don't want to flip. So I'm gonna do if P dot I think it's time to do terrain point. We're gonna add a function here where we do public byte or bool compare greater terrain data type return if type A is greater than type B. But never mind. We want to do get value type A if that one is bigger than get value type B. Then we return true, otherwise false. Compare greater. So then we can do if p dot compare greater. I don't even know if this. It's a little bit better. If this one and ooh, yeah. Okay, if this one is true, let's see, d dot compare greater terrain data type water terrain data type height. Fuck, can we make this even? Okay, if this one is true, then we do ground mesh then we do ground mesh flip quad, water mesh flip quad, and here we do false. So if this is true, we want to go back to the original layout, and then we have else if. So if this isn't true, and then I guess we want to check this one. So, or rather we want to do the exact same check, but between, we want to do it between N1 and N2. If that is true, then we definitely want to flip. Okay, so if none of these are true, i.e. we're in a case where okay, then I guess we want to check bool p above bool d above. So if p above is true and D above is true. Then we do this. Okay, else if we want to do something like this, but not exactly. We want to do, it's important that they are the same, so we can do P above so I think we can do this. Let's see. P above is equal to D above. If so, we can clean this up later on, but if this is true, then we want to have false. Like I want this one to take precedence over this one. And then else if n1 above is equal to n2 above, true. So else I'm just gonna do this. We can probably clean this one up a lot, but let's see here just if the logic is correct first. So first of all, we check the original direction. So let's take this quad here and do the tests with this one. So first we check, is this one above water and is this one above water? If so, we don't flip. If that is false, then we go to this one. So then we check, is this one above water and is this one above water? If that is true, we switch. If it's false, we check, has this one the same state as this one? If so, we don't flip. If it doesn't, then we check, does this one have the same state as this one? If so, we flip. But if it doesn't, we just leave it as is, like this. Let's see what kind of result we get. Okay, so now to the big question, is this salvageable by doing... maybe. If we randomize this, maybe. Well, but I don't really know what's happening here. This one sucks. We get a flip here, but I don't know why. Not above, not above. Why the fuck do we get a flip here? Is this one not above? Never mind. Maybe it just dries up here. Maybe. Okay. We're a little bit too conservative on when we flip and not. We flip nicely here, and here. I'm not exactly sure that this can be saved. Maybe if this one was flipped, but I guess this one doesn't have water, so we don't flip it. Yeah. I don't really think there's... I don't think the flip approach can fix this one, whatever we have going here. But yeah, I think the flow is a little bit cleaner at least. I guess we can randomize it as well. What the fuck happened here? Okay, that's rough. That I don't like to see. I need to take a double take on this one. Do a double take on it. Interesting. I think it's because... Okay, here it should be okay. But if we do here, what happens here? So we start flowing up here, and then when we do the final flow, it feels like we're flowing up to this point, right? That's not correct. Does this one affect... So something is wrong when we find stable fluid amount fluid. Oh. Ooh. Check for fluid overflow. Which if height difference is equal to p get value height minus, if this one is 0 and extremely interested in why this one overflows like it does. So we should be getting I don't get it. Water 255. We get maximum water everywhere except down here. 5. This looks bad as well. Maybe. No, I don't get it. Stable fluid amount. So we have a minima and stable fluid amount is bigger than 0. But stable fluid amount seems to be 255. Why the fuck is it 255? Hey, update stable fluid final result stable fluid. Nice. We have a update stable fluid result. 165. Here we have 165. Okay, if we update this one with 165, yeah, that feels like something we should have. 165. So what the fuck is going on in here? Stable fluid amount. Update stable fluid state. Set value terrain data type water. M.get value dot height plus fluid amount. Yeah, no. No. This works. Yeah, what the fuck? We sent it. Did this actually work previously as well? I'm pretty sure what we want to do here, and update stable fluids. I'm pretty sure what we want to do here is we want to just have fluid amount. But how come this worked previously? Let's try it. Still, oops. Ah, beautiful. There we go. Got a little bit afraid there for a second. Okay. This one. What the fuck is going on here? Why don't we get the flips I want here? Okay, this one is it never a neighbor? No, probably not. Or never mind, we flip these because we don't flip them. Fuck. We need to change the. So we want to add some extra checks here. We want to check if P has water and P doesn't have water, then we want to flip. So I think we want to do these two definitely should be the first ones, but then I think we need to check if this one doesn't have water and this one, if this one has water and this one doesn't, then we want to flip it. But actually this one should be flipped because, okay, else if N1 above or actually if P above and D above are the same, if P above and D above are the same, then we don't flip. And that's what we're not flipping here, but this one has water and this one doesn't. So yeah, they are not the same, so we move on to this one. If N1 above is equal to N2 above, so it's these two. If they are the same, then we should flip it. True. But we don't for some reason. Both of these are not above, both of these are not above. So we don't do anything of this. P above, D above, if they're equal. They are not equal. So not this one. This one is true, however. This one is false, and this one is false, right? But actually, we check them in this. Nah, I don't see. We should still see a flip here. 100%. Why aren't we? We never checked this one. Why? Okay, we start with this one. We add all the neighbors. One sec here. Which? We don't add all the neighbors, do we? We don't add this neighbor. Why not? Why don't we add this neighbor? That's really frustrating. And for this one. It's weird. We start here and we add all the neighbors. We should be adding these. So we should be adding this one. And then we move to this point. We are adding all the neighbors. We should be adding this one, but we're not. Why? What the fuck? Get neighbors. X offset. Get neighbors. Get neighbor. We're going -1 and 1. Yes. We don't add it or we don't alter it because, okay, moving to this neighbor results in no water. So the fluid doesn't spread, we don't add it to unvisited points. It's unvisited points we work with here. So okay, it's not as easy as working with only unvisited points, which sucks. We're gonna have to get neighbors again, and I don't want this. Too bad, too bad. I'm wondering... Yeah, I'm wondering about maybe... fuck it, what if we do something like this instead? Affected points. Yeah, let's do that one. Let's do that here, like we previously did. We do affected points. Let's comment this one out. And then here we do if water temporary is bigger than height, then we set water to be equal to height plus fluid unit. Else we do something like this. But we only want to do this if no, I think we want to do this for each if ap.getValue, actually compare greater if terrain height is greater than that's when we want to do this. So it's basically, first of all, we check, do we see, at this point, do we see ground or do we see water? If we see ground, then we want to visualize the flow. And if water temporary is bigger than height, then we know that we want to visualize it like this. If this is not true, then we know that it's a neighbor that didn't get enough water to be above. Oh fuck, did it? Maybe it did. Let's see what we get. Yo, what's up, Derek? What you working on? We're working on we're trying to get the trickle of water. So from the point where we add water, when it's flowing down to its minima, we want to just shape that flow up a bit, make it look less jagged, basically. Let's try and do something like this, just see what kind of result we get. And I can also show the thing we're working on. So we're working on this little trickle down here. This one. This one, trying to make it look a little bit better. This is way too thin and I don't know why. Here we want to move these up, for some reason we're not. if height is greater than water, if water temporary is bigger than terrain data type height, one sec. Then we do this, else, so AP otherwise set value water oh yeah, fuck, I fucked up. Contains n, then add n. There we go. Oh, it's way too thick. Jesus, why do we get incredibly thick? Okay, so if we add flow here, but maybe it's not too bad. Yeah, it is. Yeah, so we add flow here. So that means that we add all of these neighbors from the get-go. This neighbor is not above ground. This one is not. This one is not. This one, however, is. Or this might actually be a problem with. This one is. Yeah, we're getting way too many. Yeah, okay. So we add here, we add all neighbors. This one is above this one, and then we just flow like that. Ah, fuck. If we add to this one. We can clean this up a bit, but it's always going to be thicker than this, I think. Which, maybe not. Maybe it's okay. Maybe having it as thick as this is good. This one sucks though. Would love to flip this one. Why didn't we? This one is above water. This one is above water. Is that really it? It looks like it at least. So this one is above water, this one is above water, so we don't flip it. But what the hell? We should be flipping this one then. Not above, not above, above, above. Yes, something is a little bit amiss. This one is not affected. Okay, if we could get the quad flip to work as it should, in this case, for instance, so this one would be flipped, this one would be flipped, and this one would be flipped, then we would have gotten a pretty nice result, and then we can randomize how much below ground these should be, and it would look okay, I guess. Not the prettiest flow there ever was, but what the fuck? We flip these, but we don't flip these. One sec. Sorry about that, just thought I heard a good or a very big aircraft or plane outside my window. I just needed to check it out because it's cool. Okay. So why the fuck are we not... Here we switch, here we don't. Ify, thank you for the follow, appreciate it. This one is not above, this one is not above, this one is not above, this one is not above. This one and this one are not the same. This one and this one are the same. So why? Oh yeah, of course. It's because this point is not included. It's not included in the why? If affected points doesn't contain n, we add n to affected points here. Why are we never looping to this one? So this one adds all of these neighbors. Right, and then we move to this one, and this one adds all of these neighbors. But this one never gets added. This one never gets added. Or this one rather. Do we need to check? Nah, so when we're at this point, we pretty much only flip these. But what the hell? So this point spreads to all of these neighbors. Yeah, but then we never do this one. Oh, that's true, that's true, that's true. So what if? So what if... Is this enough? I want to do... So I wonder if we can do something like this. Minima found here. We wait with this one. We don't do... Like, we continue doing this. So get the next point, get the next point, get the next point. But... for each neighbor, we want to add them to affected points, but we don't want to spread fluid to them anymore. And we don't want to do anything else. So it's pretty much like... we want to continue doing this, like adding them here, but nothing else. So I guess we can add this one back, this one, and then we do, when we exit this one, we just want to empty unvisited points. So we just do while unvisited points count is bigger than 0, and we do for each p is equal to unvisited points dot first unvisited points dot remove at 0. I just want to see what this happens, and then we do for each rn in p dot get neighbors, and the only thing we want to do in this for loop is this, pretty much. Okay, so we do this until this one is empty or minima is found or cancellation token. But when we have found a minima, so when this is true, we exit this one, but this one is not empty, so we just empty it out and add all the neighbors into affected points because we want to change the mesh based on those, and then we do this. Maybe. Yeah. Yes. Beautiful. I don't even know. I guess we added here. But I mean, it's extremely... What happened with this one? Fuck. Yeah, we definitely want to flip this one. But I mean, it still looks... It looks quite rough. But maybe we can... Maybe we can make it look prettier. Can we? So in this one, for instance, if we right now every neighbor outside has the height -1, what if we randomize this one So we get into here, maybe into here. Maybe. Still, it looks extremely thick. Yo, what's up, Love? It's going pretty good, I would say. How about you? Oh, beautiful. Yeah, if we can get the edges on this flow to look a little bit better. Good to hear. I've been checking the YouTube recaps. Appreciate it. Yeah, it's been progress still, but it has been rough at certain times. I'm good, thanks. Back at work after a week in Cyprus. Damn, nice. Nice. Was it a week of vacation or work? I think Cyprus this time of year is way too hot for me, I think. Okay, let's see if we can randomize the edges here. So instead of doing -1, I want to do minus. Let's try and do random dot next, and we go between 0 and fluid unit +1. But if we do 0, it might not look that good, but let's try. Oh, a wedding. Damn, nice. Yeah, like right now in Sweden it's pretty hot. I think this whole week is going to be pretty hot. I'm just trying to survive. Everything above 22. Yeah, let's try the flow over here, please. Oh, we're getting closer. I can work with this, I think. But we can see here that the ugliest parts are definitely when we have the same, when we have water that is right. Yes, we want to avoid that. If we can avoid that, I think it will look way better. It's beautiful. This sucks, of course, but this has to do with that the water doesn't have any, it doesn't really have any offset in the Y position. So the water and the, so if the ground height is 0 and the water height is 0, you get something like this. You get like the water overlapping the ground, even though it shouldn't. We're gonna get to that soon. But okay, this. So what if we do 1 here? So if it's a point that is below ground, we always make sure that it's actually below ground. I think we're done. I mean, it's still extremely... Look at these randomized edges. Love it. Like, it's still extremely thick. I would like to have it... It depends. It depends. Like, if the character is adding water by hose, I would like it to be thinner. If the character is adding water by a bucket with infinite water, I could definitely think something like this. And then I guess we want to animate the height of the edges as well. Maybe. Maybe. It looks way better than it did, at least. So it's like this. Let's assume that the character stands here and we add water to this one. We get this flow and then it becomes bigger. Then we stop adding it. This one gets removed. At certain very specific points, we get edges that are questionable, but I think it's still acceptable. We might be able to save it with the shader. And then again, I don't know about, like, maybe we will even go one resolution bigger, so the resolution might save us, but I don't know. Could do now this resolution might be good, but we might do tessellation. I don't know just yet. I think we get 1 point right about here. I'm not entirely happy with how this one looks here, although could we make this flip? So this one is above water, this one is not, so we don't do anything. This one is not above water. This one is above water, but this one is not, so we don't do anything. Then we check this one is not the same as this one, so we don't do anything. This one is not the same as this one, so we don't do anything. Which means that we keep it as is, but I wonder... Like, if that's the case here... let's see. Here. So in this case we want to keep it, but in this case we don't. What makes this case different than this one? But one sec. This one. I wonder if we want to rotate it based on this is a very, very special case. I guess we would like to flip here as well, right? This is the same case as this one. I think we would like to flip here as well. But this one, for instance, we don't want to flip. Ah. This one we don't want to flip. I wonder if we can go... If D... Nah. I don't really know how we can decide that we want to flip these, but we don't want to flip these. Without, like, we don't want to mistakenly flip this quad, for instance, or this one, I mean. But maybe, or this one. In fact, do we want to flip this one? Well, maybe we do. But we don't want to flip this one. This one is the worst one. So I guess, could we... Okay, if everything else fails, we want to check if this one isn't above surface level, then we want to flip. So we're gonna flip this one and this one. In fact, we're gonna flip this one as well. We're gonna flip this one. We're gonna flip this one. Nah, we're not gonna flip this one. We're not gonna flip this one, but we're gonna flip this one. Will that screw things up? In fact, let's try it. Let's just see what we get. So we want to add one extra stuff here. So else if P above flip that shit. Oh no. If P is not above, flip it. I think. I don't know. Yes, we flipped them here, we flipped them. So this one, for instance, we would have flipped this one the previous time around. This one, for instance, we flipped now, but we wouldn't have the previous time. That's good. Maybe it's better, I don't know. Or actually, we want to check. No, I think it's a too easy check. I think we want to check it. I'm gonna have to think about that one, but I think instead of doing a check like this, What we want to check instead is actually, we want to check like if P above and N1 above do something. As like we want to check the neighbors. So here we check diagonal neighbors, opposite diagonal neighbors. Here we check diagonal neighbors, and then I wonder if all else fails, we start checking ordinary neighbors. Maybe. Yo, what's up, Harukanan? So for now, I think this is the preferable result. I think. So this one, for instance, we have checked, is this above, no. Is this above, no. Is this one and this one the same? No. Is this one and this one the same? No. So what do we want to base this, what do we want to base the flip on then? And I'm thinking, like this one we want to flip. Just came back from the, is it physiotherapist on English? Is that how you pronounce it? Time to start bicycling. So tomorrow I will be back at the office again. Nice. Happy for you. Happy for you. Like, how long has it been? Was it just before summer you broke it? In June or something like that? Oh, still pretty quick rehab, I would say. This one annoys me. "23rd of June", so surgery was 9th of July. Okay, so like, what is it, 2 months since the surgery, basically, and then you're back. Pretty good, I would say. Pretty nice. Like, I remember I broke my arm, or I didn't really even break it. I think I just got a crack in it, and I had to have a cast for 8 weeks, and then it was like 4 more weeks after that to get it back to how it used to be. So yeah. What does this quad want with me? Fuck. What rule can I say here that should flip this one but not the other ones? Yeah, we want to go it's something with counterclockwise and clockwise. So we want to flip it because, well, let's see, if we go, I think, because we don't want to flip this one, or do we? In fact, maybe we do. I don't know. Yeah, stuff gets stiff and you lose a lot of muscle mass. Yeah, that's one of the worst things I remember from when I broke my arm. Like when I had it in a cask, I had to have the arm at a, what is it? I should know this, 90 degree angle for 8 weeks. So, what muscle is it? It's the bicep got dull, is that the word I want to use? And the tricep got weak, so I had a really hard time dragging my arm out. Yeah, if it makes any sense. Was that going sledding in the snow when you were 13? I don't think, I've broken my arms twice. Once from playing football, I think, and once from dangling from a basket. Whatever you throw the basketballs at. I think. Fuck. It's a little bit sad that the childhood memories are starting to disappear. Fading out of existence. Hadouken, so it was a stress fracture in the upper arm bone. Yeah, could very well have been. I think we want to flip it in such a way. I think we always want to flip it in such a way that P has water if it's possible. So if we flip it here, then P has water. So if P doesn't have water and N2 has water, then we want to flip it. But what happens here? P doesn't have water, N2 doesn't have water, so we don't flip this one. And yeah, I don't think we want to flip this one. But P, yeah, maybe that's it. Have I broken it? Maybe. I want to try it real quick. So if basically else if P is not above and N1 no N2 above, then we want to flip. I don't know what the hell is happening here. Looks pretty... I don't know. Maybe. Maybe. I don't know. I don't know. Ooh, that looked rough, by the way. But yeah, I think we're flipping this one now. It's not too bad. Not a big fan of the... Oof, this looks good. Fuck, this looks good. This looks like shit though. So what the hell is happening here? I hate this one. But then again, I don't know if this is a very specific case when we have a height of 0. But yeah, this flow down here looks very good. It might very well be. And this, I wonder if... Yeah, we probably want to base this one on... The higher this one is... It looks so damn good sometimes. Yeah, maybe I should just call it on on the water stream. Like maybe it's in an acceptable state for now. Still, like there exists a few like worst cases. This one I'm okay with. This one I'm definitely not. What the fuck is this? Seriously, what is happening here? We add water here, I suppose. Check all neighbors. This one gets water, this one gets water. It looks like shit. What we could do... Oh, 1 sec. I did one change, which I didn't change back, I don't think. Where do we have it? Fluid solver. Where is it? Spread fluid, diagonal cost. Do we have diagonal cost? 0, 1. Yo, Derek, looking good. Yeah, slowly but surely. Chipping away. I'm starting to think that we might be able to do this without having a channel called water temporary. We might not need to use that one, actually. That would be beautiful. So water previous, water temporary, timestamp. We could skip this one. Very interested in how it's going to look when we have timestamp to work with as well. Let's see what happens if we do this. This one, yeah. Very specific case. What can we do about it? I think we're adding fluid here. I think we're close to what we want to do here, but not really. I'm wondering if we're a little bit too nice here. So what if we also do we do spread here as well? We don't add them to unvisited points, but we spread from P to N with dry constant diagonal cost and water temporary. And then we do this. And we don't need to do if then. So, let's see here. We spread and okay, maybe now we're maybe even nicer. So yeah, let's take a look at this one. Now we're way too nice. And we have the same issue as previously. Fuck me. Oli V, thank you for the follow, appreciate it. Yo, what's up, Oli V? Okay, so basically we add all neighbors. One sec. We add all neighbors. I wonder if we want to do... We want to be more conservative. So I wonder if we want to do... For all these neighbors, we have already spread fluid to... let's see here. Unvisited points. Yeah, we have spread fluid to them, but maybe we don't want to. So maybe we should do... We add them to a... One sec. Yeah, we add neighbors here. We add neighbors. We don't spread to these neighbors. Derek, are you no longer using the diagonal fixes you were working on, or is it a different issue? So we had two approaches to getting the edges of water looking nice. The first approach gave the best result, I would say, and that was when we interpolated the vertices along the diagonal. But it came with a lot of different problems. So always when you displace vertices, you have to recalculate a lot of things like normals. and we needed more and more information, and we couldn't, or I couldn't really get it to work with not introducing too much calculations and stuff like that. So another approach was to just, because we knew that edges of the water always lined up good if the edge follows the quad split. So the second approach is just to do some additional checks and flip the quad split if we have a bad what is the word, intersection between water and ground. And what we're doing now is, like, when we start pouring water, we have a very thin line of water going from the entry point down to the minima, and I'm just trying to get the mesh of that one to look a little bit better before we jump into shaders. Unfortunately, it turned out to be a little bit harder than I thought. Let's see here, we spread fluid here, so some of these points might be above ground, but we don't want them to be, so we might just do, when we do this, these will have 0, so I'm thinking of doing this as also p.setValue terrain data type water temporary to 0. So this is a point. We have spread water to this point, but before we have spread that water to different neighbors, we notice that we don't actually parse through this point, so we set the water temperature to 0. Like what we want to visualize in this at this point is a thin flow of water down to the minima. So we want to be conservative in how many vertices we include in that flow, and hopefully this will constrain it a bit more. But you never know. Got it, I think. Best one yet, at least. Best one yet. Best one yet. But that was just one case. Maybe it looks like shit here. This bothers me more than this. Fuck it. I need to... That's how we want it to look, pretty much. This is a beautiful flow. So if we add water here, we always want to have... We always want it to spread up, right, down. We always want to include those. The problem happens when we spread a diagonal as well. Yeah, but it can definitely work with this one, I think. This one is rough. How could this one be saved? Why is it so rough? Yeah, this one could be saved. if we flip this one. Or could it? Yeah, I think so. Ah, maybe not. But now with this solution, when we have constrained the initial flow like this, we can probably go pretty crazy. Wow. We can, I think we can go pretty crazy with these points. We can probably put them above as well. So I wonder what happens with this flow if we do. So here we do height, random, we add random here, and one is negative fluid unit, and one is fluid unit plus 1. So we take the height of the ones not included in the flow, and we put we randomize the water there, and we put it between minus fluid unit and plus fluid unit. So we constrain it a bit more here. We're very conservative here. But this, by being that, it might open up for us to be more or less constraining here. Let's try it. I wonder if this might lead to some not so good flips, or yeah, quad flips, but we'll see. We're gonna start with the easy test, which is here, I think. Oh, jeez. Okay. What the fuck? Okay, I get it. I think. Looks pretty cool. Okay, so what we definitely don't want to do is this can never ever be above ground. But I wonder if we could include, so these, the P's here, these are neighbors that are directly connected to points that should have water. So maybe we can be less constrained about these. But with this one, we're still very much constrained. So maybe want to try. Let's add this one here, and then we do, instead of setting the value to be this, we set it to be oops. So we do this here. Oh, no. I want to set it to be and maybe. And here we definitely want to do this. Nah, we're doing worse and worse here. That's rough as fuck. Although I wonder. Yeah, basically what we're doing here by setting this one to 0 is that this one will never complete, so we will always get this value. But I would... I don't know. Or actually, do we have a max? Maybe we do. Ah, beautiful. A fluid, do I want to call it that? Yeah. So previously we put all of them to be equal to fluid. Now we just do the max of water temporary and fluid unit. I'm trying to introduce some form of variation that can round the edges, basically. One sec. The fuck. Whoa. Ah, we do. Yeah, we do max. I don't know about that. Yeah, we do max here. That's not good. I think I want to go do min. Why don't we get more randomization between this one? Like, it looks like this and this are pretty much the same distance, but then again we're just randomizing between 0 and 5, I think. So, like, I'm not seeing. Yeah, I think we want to randomize a bit more here, I think. Fuck, I hate this. I hate that when we get a straight line like this. Fucking sucks. I hate it so much. Yeah, before I try and analyze that, I just need to run AFK real quick. Berbe. Okay, back. Sorry about that. Yeah, this straight edge here really annoys me. And in this case, we're flipping it, but I don't want to flip it. I guess it would look nicer if it wasn't flipped here. Find it a little bit weird. There we go. So like in this one, why are we moving? Why does it look like it's... Why does it want to move diagonally like this so much? Ah, yes. Unvisited points ordered by height. No, I think we want to order them by water temporary. But order by, yeah, order by. So yeah, the one we're always gonna get, like water height, it's gonna decrease the most in the direction with the most decrease in height. And we also have, if we move diagonally, but that's only if we move. That's only if we move in parallel. I would like this one to be... I think I would like this one to be active here as well. Maybe not when we move upwards, but when we move downwards. So here. So if this is 0, we don't get anything here. If this one is 1, we get... Let's try it. Because previously it's like, yeah, the water wants to, it moves in a diagonal fashion, and I don't like it. I don't like how it looks. I want it to zigzag. Okay. Did I screw up something else by doing this? Yeah, we're not finding the correct minima. The fuck? So add a diagonal cost here. Mm. What? Okay, so the problem seems to be when we don't find a minima in the first iteration. Or if we do... And that works. Why the hell are we finding a weird minima here? It's making sense. What the fuck? Oh, yes. What the hell? We add P here, and we do something with P here. Ah, fuck me. Terrain point. What do we... A terrain point, I guess. Unvisited point. And then we do UP. I'm still a little bit weirded out that this didn't mess it up even more. So something like this. Okay, let's try this. Water temporary diagonal cost. Because this method always returns the minima and we set that minima to another point by mistake. Or I did. So what do we have now? Yeah, we still have the problem with the start point being cut off like that. Not a big fan at all. But that sucks as well. beautiful. Beautiful flow. I wonder, let's take a look here. Maybe it's acceptable enough right now. If you take a look at this one. Oh, what? Yeah, like maybe it's acceptable enough, and then we can tessellate it in the shader and distort it, the edges. So tessellate here, give a few, yeah, maybe. What's up, Playlizard? Still looks a lot like it always wants to move in parallel for some goddamn reason. Or in diagonally, I mean. What is that? Why does it prefer this way? Oh. One sec. Oh. Yeah, okay, so it costs more moving diagonally, and then we sort them on the one that has the least amount of, so we start with it. Yes, of course. We can't do it on max. Fuck. This is good, but like when we do diagonal cost here, we actually yeah, I think we want to sort them based on, we definitely want to do this, but we want to sort them based on you get value, you dot get value, terrain data type height minus this one. So the one with the most water. Buff. But then we want to do it by order by descending, I think. So the difference between height and water height, so the one with the most water, we want to start with that one. If we move downwards, yes, let's try it. it actually lead to us getting a thick like this one? Yeah, maybe not when it's that much cheaper to move. What the f... Did we actually make it that costly? The fuck? I'm not too sure about this one. Yeah, unfortunately we made it way too costly to move. What the hell? Oh, I see. Mm. Mm. Order by descending. Get value height minus get value water temporary. Ah. We want it the other way around. What the fuck? So we want water temporary here and height here. We always want to start with the one that has the most actual water fluid or water amount, not height. So yeah, maybe this is it. Ah, still looks like shit. This one looks good. This one doesn't. What the hell is happening here? Is it really that much costlier to go? Yeah, I guess. Order by. So we ordered them by. Order by height. That's what it was previously. So we always want to take the one with the smallest height. But if we have 2 points that has the same height, we always want to take the one that is closest to the one we're currently at. Ooh. So pretty much is it compared to this one? I think so. So I wonder if I want to do order by get value, then by u vector 3 dot distance between p dot terrain path dot position os or p dot position. Don't we have terrain point? No, we don't. Okay. Public vector 3 position os. P dot no. We want position world space. So we do position world space and u dot position world space. So unvisited points order by height, so we get the one with the smallest height first. But if we have 2 with the same height, then we want to sort them so we get the one that is closest to this point first. Fuck, is that how we want to do it? It's always... I guess it depends. Maybe. Oh, yes, of course. Get transform can only be called from main thread. Position world space. What do we do here? Position world space. We do transform dot position plus position world object space. Yes. Transform dot position. Like, yeah, we could sort them based on x and y as well, the distance between x and y, but that won't work with terrain patches, I don't think. But maybe that is such a special case that we don't really care. So if we do terrain point, yes, we can't do these because it's not thread safe. Vector 2. No XY. So what if we sort them based on those coordinate distances instead? So do then by p dot chords and u dot chords, and we do vector 2 here. Shortest distance first, yes. It still wants to move diagonally and it fucking sucks. The fuck? But actually, maybe that makes sense. I don't see anything wrong with the calculations here. Maybe it looks good here. I think there's a improvement. Got some ugly stuff going on here, but PG King, this looks so freaking good. Yeah, actually it does. This flow is pretty damn cool, actually. This one I like. But I think we can clean this up. We're gonna do some small tessellations here later on, both on the water and both on the terrain. So the closer we are, the more we're gonna tessellate it. I think. Whoa, we had some rough ones there. Okay, I think I'm gonna let, like, this is an acceptable state. Although we still have this case, which I haven't really tried. So we try and find a minima, and we're always gonna get this square-like monstrosity. It's because... Ooh... Yeah, we want to make it more round. Definitely. Very interested in what happened there. We found a minima here. Start. So as soon as we find a minima, we get something weird like this. Why? So we find this minima. Fuck, I actually like this. But what the hell? Is it this one? Yeah, it definitely has to do with the fact that we set water previous in water. Find reachable minima. Then we do update fluid mesh data and flip quad. Update fluid mesh, apply data. Okay, we haven't found a minima. We jump down here again and again and again and again. Yeah, okay. I guess we're screwing things up with this one right here. Because we're not resetting affected points between... There's something I've been thinking about doing for quite a while when it comes to this system that will simplify a few things. And maybe, yeah, it will improve the performance as well. And that is, so right now we always keep track of, we have a list of affected points. And we have a list, or that's pretty much all we have. Affected points are both points that get water and edge points. I want to make a distinction between those, I think. So that we have affected points, or visited points, I guess. Or affected points. And then we have edge points. And edge points are always points where we failed to where spread fluid failed for some reason. So these ones, for instance, wouldn't be affected points, they would be edge points. We wouldn't do this here, we would do affected points here. And if this one fails, we add, or if this one succeeds, we add them to unvisited points. If it fails, we add them to edge points. How would that look? Maybe that will be what tomorrow holds. Because, okay, we're in an acceptable state at almost everything, but there's still some weird cases. Coolers K, are we winning in water? Fuck yeah, we're winning at water. But if we work with edge points as well, we're gonna be able to... I've been talking about this one a lot, but there exists one improvement we can do here. Or basically, like every time we enter this one, we start from the same point and move outwards. We do a lot of the same calculations multiple times. Instead, we would just fill up the points we have and then move outwards from the edge points. And we're gonna work with edge points. But will the concept of edge points work between... Do we reset? Oh, do we actually clear water temporary here? I'm not so sure I want to do this. Maybe that's the biggest problem. We definitely want to clear it up here, I think. Yeah, here. But not here. What the hell? I wonder if that's the... maybe it is. Let's see. Do we don't? Ooh. Let's just put it there real quick. I want to try this because I think the visuals we get here are because that we cleared this one in between. I think. Ish. It's better now at least, I think. Ooh. Interesting. Interesting. Okay, once again, like worst case scenario right here, but still want to make that one work. Might have an idea of what it is. No Cooler SK, no fish yet. But yeah, I gotta run now. Still happy with the progress today. I think it's looking better and better. And we haven't even started with the shader yet. So yeah, thank you so much for watching, everybody. Appreciate it. Thank you, PG King. And thank you once again for the Prime, by the way. Hope you all have a wonderful rest of the day. Peace.